Welcome back to my YouTube channel. Okay, now for the UTME student, please come closer. Now look at this question on the board. We have UTME 2023 question 1 and 2, physics. Question 1, we have coefficient of friction between a perfectly smooth body and a very high rough surface is which of these options? We have the first option to be 0, the second option to be 1, option C is 1/2, and then option D is what? Infinity. Now, the first thing is, please, like I always say in all my videos, the noblest pleasure is the joy of understanding. Reading without reflecting is like eating without digesting. So it is important for you to understand a question. Try to study hard and make sure you understand every concept when it comes to any topic you are. But what is important is to understand the question so that you won't pick the wrong option or the wrong answer. Now, when you have a question like this, let's say there's no option, how would you be able to answer questions like this? The first thing is, what is friction? Friction is a tangential force. Okay, I have to say this because some of my students said I like to explain and all that. Yes, it is important. I'm not treating topic. I only solve questions. So if I'm going to treat a topic, I always make sure I explain so that my audience, my viewers, they will understand. Okay, they can pick one or two things from whatever I am saying. All right. So now we have the coefficient of friction between a perfectly smooth body and a very high rough surface. Very high rough surface. I wouldn't know if we can combine, very high rough surface. That sounds weird. Okay, all right. So now we have the coefficient of friction between a perfectly smooth body and a very high rough surface. Now, when we say coefficient of friction, now for friction to be present when one body, okay, is sliding, okay, over the surface of another body, then it means the surface will be rough because we have laws of solid friction. Laws of solid friction. We have two laws of solid friction. We have laws of static friction and we have laws of dynamic friction. So for those of you who want to study engineering, okay, most especially mechanical engineering, so it is important for you to know that there are two laws of solid friction. We have law of static friction and we also have laws of dynamic friction. Okay, now because there are a lot of aspects of friction that involves calculation. Okay, and you are going to apply all of this. The two laws will be applied because dynamics or kinematics. All right, so we have the coefficient of friction between a perfectly smooth surface. So why we have coefficient of friction is because the surface is rough, and that's why coefficient of friction, okay, can be expressed as a constant ratio of the limiting frictional force to the normal reaction. When we have a body lying on a rough surface, this is a rough surface, okay? So the frictional, this is the normal reaction, which is R, okay? So let's say a force acts on this body. So that is a tangential force. Now, because the surface is rough, then a tangential force, will now act to oppose the motion of the object sliding over the rough surface that are in contact. That is the motion of this object sliding over the rough surface of the other. This is another body that are in contact. So in this case, if you want to measure coefficient of friction, let's say we have the force to act at some angles to the object, then we can also measure coefficient of friction. But what is important here is now I said coefficient of friction, okay, bears a constant ratio of the limiting frictional force to the normal reaction, okay, because we know that The frictional force is coefficient of friction multiplied by R. One of the laws states that the force of friction, that's for the two laws, statics and dynamics, the force of friction is proportional to the what? To the normal reaction between the two surfaces in contact. All right. Then at the same time, the constant of proportionality there, which is coefficient of friction, and that is why the surface is rough. Okay. Now, also is also one of the laws, and like I said, it's a constant which can be expressed as the ratio of limiting frictional force to the normal reaction between the two surfaces in contact. Now, to be able to answer this question, now we have the coefficient of friction between a perfectly smooth body and a very high rough surface is what? Now, please don't mix it up. Now, coefficient of static friction, static friction is that frictional force that oppose the motion of initiation between two surfaces that are in what? In contact, or it is that frictional force, okay? The frictional force, okay, experienced by a body which tends to move over the surface of another body. All right, so coefficient of static friction is greater than the coefficient of kinetic friction. That is motion, when there is motion. So when we have a very high rough surface, that means the friction is high. That means friction is present because the surface is what? Is rough, and we have a very high rough surface. But when we have a perfectly smooth surface, that means friction is not present. But in the case of a very fluid and a viscous force, okay, V is a viscous force when terminal speed is reached, then by a falling body. When a body fall through a fluid, now as it fall through the fluid, okay, the downward pull, okay, the downward pull, or let me say the downward force, or the force of gravity acting on the object, okay, when the object move through the fluid downward, will be the what? Will be the weight on the object. So we have the object, okay, is moving through the fluid downward because of what? The weight of the object. That means the weight of the object is the downward force. Now, two force will now act on the object, okay, when terminal speed is reached. Yes, because we have viscous force to be V. So the viscous force is an upward force, okay, and also the upthrust or buoyancy or buoyant force is that upward force which will act on every object immersed completely or partially in a fluid, and it is a vertical force. Okay, it will act vertically upward. So the two forces, we have the viscous force and also we have the upthrust, okay, in a fluid. Okay, now the body move through the fluid downward. So that is because the gravitational force, that's the force of gravity acting on it, okay, will develop an acceleration on the body in that direction. But two forces now will now counterbalance the downward force. According to one of the principles of equilibrium or conditions for equilibrium, we know that the total upward force equals to what? Total downward force. So the total downward force will be what? Weight. And the total upward force will be what? Will be U plus V. U plus V. Okay, that will be U plus V. So when terminal velocity is reached, okay, the total force or the net force acting on the what? On the body, on the falling body will be equals to 0. And the weight, I said the sum of downward force equals to sum of upward force. So that means W will be equals to U plus V. Okay, so which means the sum of these two forces, that is W negative U minus V, will be equals to 0. This is the answer to the question. This is the answer to the question. So, but what we have here is we have A, for option A, we have V equals to mg over what? U. This is wrong. Okay, then for option B, we have V equals to mg plus U. This is also wrong. because it's meant to be. Now mg, remember, weight, which is the force of gravity. That's the force acting on an object due to what? Gravity. So that's force of gravity, and that will be what? Mg. That's force acting on an object mass due to what? Gravity. Is called force of gravity near the center of the earth. Now I like to say all of this because that's what makes teaching beautiful. For those of you that you are preparing for WAEC exams, fine, yes, I like to explain, I like to give explanation so that when you can just, in your quiet moment, you can take time, you could actually take time, to write some things, okay, just for you to remember, and also to be able to remember that I said, this is what I said about weights, and this is what I said about viscous force and the rest. So now we have here mg equals to v plus u over 2. This is not even correct at all. There's no law that explain this. Okay, no law also explain this. Viscous force, terminal velocity, and what have you, they are not related by this equation. Okay, this looks somehow like what we have here, but no, the answer, this is not the answer. Now look at what we have here. We have v equals to mg. Now v can only be equals to mg when u, which is the what, the upthrust, is what, is negligible. So when the upward force is negligible, so we can say that, okay, fine, w equals to the viscous force plus the what, upthrust. Now when we say upthrust, when the upthrust is negligible, that's small, very small, that's so infinitesimal. So when the upthrust is negligible, or we can just, so that means it will be equals to what? It will be equals to 0. So that is u equals to 0. So we can have w equals to v, so that the mg can be equals to what? Can be equals to v. But don't forget I said the total force or the net force on the falling body must be equals to what? 0. This is the valid. So which means, okay, fine, when this is equals to 0, then w will be equals to v, which in this case as well, if we put u equals to 0, then v will be equals to mg, because we know that w is equals to what? Mg. Remember, the quality of your preparation will always determine the quality of your performance. So get starting. Bye bye.